Example 1. Sketch the region defined by the inequality y less than x. In this example, there are two main considerations. The first consideration is to define the boundary of the region to be shaded. And the second consideration is to shade the region that satisfies the original inequality. To define the boundary, you can replace the inequality symbol temporarily with an equal sign. So we have the line y equals x, and that's drawn here. So it's just a line of gradient 1 that passes through the origin. Notice that the line is drawn dotted and not solid. And that's because the inequality is a strict inequality where y is less than x, not y is less than or equal to x. If it was y less than or equal to x, the line would be shown as a solid line. But in this case, because it's y is strictly less than x, the line or the boundary is shown as a dotted line. Next, we need to determine which part of this boundary is to be shaded. So this boundary here, y equals x, separates the Cartesian plane into two regions. So we have a region that's above the boundary versus the region below the boundary, and one of those will be shaded in. So to determine that, we can choose a test point. And you can choose any point you like on the Cartesian plane, any region you like. So we can either use this region here or this region there. Now I've chosen this test point here, 1, 0. So x equals 1, y equals 0. So this point here, the x-intercept. And I'm going to test if this point lies in the region to be shaded in. So we're going to check if the inequality holds true for this particular point. So the inequality is y is less than x. So y equals 0, less than 1. Is that true? Yes, it is. So this point here will lie in the region to be shaded in. And then finally, we just shade in the relevant region. So if the test for this point here comes back false, then clearly this point would not be in the region. It would obviously be the other side here. We'd shade that in instead. But in this case, because 0 is less than 1, then the point 1, 0 is in the region to be shaded, and we just shade in then the relevant region. So we just shade it in, and that's it. Example 2. Sketch the region defined by y greater than or equal to x squared. Our first step is to define the boundary of the region. And we do that by letting y equal x squared and drawing its graph. In this case, it's a concave up parabola where the vertex passes through the origin. Notice that the parabola is drawn with a solid line, not a dotted line, like what we did in example 1. Because the inequality is y is greater than or equal to x squared. So the curve itself is also part of the region or part of the solution. Next, we choose a test point. And you can choose any point on the Cartesian plane. So either above the parabola or below the parabola. I've chosen a convenient point above the parabola. And I've chosen the y-intercept here, which has coordinates 0, 1. Now we need to test this point against the inequality. So this test point 0, 1 doesn't satisfy the inequality y greater than or equal to x squared. Now y equals 1. 0 squared was just 0. 1 is greater than or equal to 0 squared, which is true. So this point here, this test point, is part of the region to be shaded in, or it's inside the region to be shaded. So our final step is to shade in the relevant region that satisfies this inequality. So that's this region here above the parabola. Example 3. Sketch the region defined by x squared plus y squared greater than 1. Firstly, we'll define the boundary of the region. And we do that by temporarily replacing the greater than symbol with an equal sign. So we have x squared plus y squared equals 1 is a circle of radius 1 centered on the origin. Notice that the circle is drawn using dashes or dots, not solid, because it's a strict inequality. If this was x squared plus y squared greater than or equal to 1, then the circle itself will be drawn solid because it's part of the solution. But in this example, x squared plus y squared greater than 1 x squared plus y squared equals 1 is not part of the solution. And again, that's why it's shown using dashes. Next, we'll choose a test point. Just choose any convenient point on the Cartesian plane. I'm going to choose the origin. So that's the coordinates 0, 0. And we're going to test that point against the inequality x squared plus y squared greater than 1. So on the left-hand side, we have 0 squared plus 0 squared, and of course that's 0. On the right-hand side, we have 1. So 0 greater than 1, well, clearly that's false. So the region that's going to be shaded in is not inside the circle, it'll be on the outside. So the final thing we do is to then shade in the correct part of the Cartesian plane. So we're going to shade outside the circle, and that is the sketch of the region defined by x squared plus y squared greater than 1. Example 4. Sketch the region defined by x less than or equal to 1 over y. The boundaries that define the regions in this example are more elaborate than the previous 3 examples. We have the hyperbola x equals 1 over y, and it's drawn as a solid curve, of course, not a dashed curve, because the inequality is x less than or equal to 1 over y. But we also have the horizontal asymptote and the vertical asymptote as well. So we have several regions here that need to be tested. So I've used 4 test points to test these various regions. So in quadrant 1, we either shade above this part of the hyperbola or below it, of course. And I'm going to use the test point 2, 2. So testing 2, 2 using this inequality, 2 less than or equal to 1 over 2 is clearly false. So the part of quadrant 1 that needs to be shaded. So remember that this part of the asymptote, this vertical asymptote here and this horizontal asymptote here form a boundary, but so does the hyperbola as well. So the test point here clearly fails. So we're going to shade this part of quadrant 1. Now let's have a look at quadrant number 2. So negative 2, 2. And that's this one here. So negative 2 less than or equal to half is clearly true. So this entire region here, so all of quadrant 2 will be shaded in. So I'm just going to continue the shading this way. Now let's check quadrant 3. So negative 2, negative 2. So this is the test point here and the test. So is negative 2 less than or equal to negative half? And that's clearly true. So we'll be shading under the hyperbola, or this branch of the hyperbola. So we'll just shade this part here. And next we'll check quadrant 4. So 2, negative 2, and that's here. So is 2 less than or equal to negative half? No, it's clearly false. So no shading needs to be done here. So this is the solution in the end. Example 5. Sketch the region defined by the intersection of y greater than or equal to x squared and y less than 1 minus x squared. The boundary in this example is formed by the intersection of 2 curves. We have y equals x squared, which is a concave up parabola, vertex at the origin, and it's drawn as a solid curve because y equals x squared is part of the solution. We also have y equals 1 minus x squared with vertex at the y-intercept of 1, and that's drawn as a dashed curve because y equals 1 minus x squared is not part of the solution. Let's consider y equals x squared, and let's pick a test point 0, 2. So testing 0, 2 using this inequality, y greater than or equal to x squared, we have 4 greater than or equal to 0 squared, and of course that's true. So what we're going to do is we're going to shade that part of the region first, like so. Now we'll consider the curve y less than or equal to 1 minus x squared, or the region bounded by that curve. And I'm going to use a different test point. I'm going to use the origin this time. So just ignore y equals x squared for a moment and just focus on y equals 1 minus x squared. The test point 0, 0. And we're going to test that point on this inequality here, y less than 1 minus x squared. So 0 less than 1 minus 0 squared. Of course, 0 is less than 1. That's true. So this part of the parabola is going to be shaded in, or at least this region is going to be shaded in. Now take note of where the two regions overlap. That's the intersection. And in fact, that's the solution. So where the two regions overlap, let's shade that in. I'm going to shade that in a different color. So where it's shaded in red is the intersection of y greater than or equal to x squared and y less than 1 minus x squared.